This diagram, actually, this diagram shows two weather satellites, goes west and goes east, which is currently providing all of the weather data to the National Weather Service, and so for the United States and the Western Hemisphere. And these two satellites are in geostationary orbit. They're about 10 years old, and they're coming to the end of their lifetime. And they're going to be, it has to be replaced. So late last November, a satellite called GOES-R was launched. And when it got into geostationary orbit, it became GOES-16, and it's in a parking orbit to replace one of these satellites, either goes east or goes west. It's been announced that GOES-16 will replace GOES-east, so it's going to move from its parking orbits. This is a fourth generation of GOES satellites, and the ones that we have currently in operation have a certain number of instruments, but this new one has a global lightning mapper, an instrument that can actually see flashes, individual flashes of lightning, and actually accumulate, actually make lightning diagrams, and even time-lapse images of flashes of lightning as storms progress. And we'll go to the next image because the GOES-16 satellite, since it's still in parking orbit, is undergoing a test. It's currently going test and calibration for about a year until it becomes operational in November. Here's an example of an image taken from its lightning mapper. This basically shows the amount of energy released in lightning in various parts of the globe. The yellow is very, very high energy, and red is low energy, and nothing down there is no energy. And we'll go to the next video, which is taken by the Global Lightning Mapper. This was taken from April 18th to May 7th, and you can see the amount of lightning on those storm fronts. This is going to be very helpful for predicting when dangerous storms with hail and lightning and high winds will occur, and will provide advance warning, especially for land and sea, and even aviation traffic as well. So it's very useful, and indicates some of the patterns that you see in storms, where when a storm approaches, most of the lightning usually occurs on the front end of the storm, and then you get heavy rain, and then then you don't hear much lightning or thunder afterwards. It's usually our experience with thunderstorms. So we can go to the next slide, and just this is a beautiful aerial view of lightning in clouds, but a very useful instrument that will add to our understanding of lightning, and also help provide advance warning to cities and towns.
I'm also struck by the quantitative nature of that, how much energy is released. And again, in the spirit of how science is done, comparing that to models, being able to constrain models, how the energy flows through the electric field, magnetic field, and how the buildup of storms can release, and those very detailed quantitative measurements, besides looking really cool, where all the little flashes are.